And so we come to the last major topic for our class, correlation and regression. And if you don't know what those words mean right now, that's fine. I'm going to try to explain what they mean before we're done here. But let me start with a question. In a math class, do people who do better on homework also tend to do better on tests? You'd think so, right? But how could we study this? How could we find out for sure if this is true or not? Well, I went back and looked at one of my old classes from the previous semester. And for the students in that class, I looked at what their homework average turned out to be for the semester and what their test average turned out to be. And just looking through these lists of numbers, it looks like people who got a really high homework average also got a really high test average. And people who got a really low homework average also tended to get a really low test average. Now, it's not 100% true. Like here, I see somebody who got a 74 on homework, but only a 37 or 38 on tests. Here, I see somebody who got a 57 on homework and a 78 on tests. I'm rounding to the nearest whole number. But mostly, people who scored high on homework, looks like they scored high on tests. People who scored low on homework did low on tests. People who scored somewhere in the middle on homework mostly scored somewhere in the middle on the tests. And we could get a better feel for what's going on if we represented this graphically with what's called a scatter plot. And this is what that would look like. You see a bunch of dots here? Every one of these dots comes from one of these pairs of numbers. You treat the first number as like the x coordinate or how far across that dot is, and the second number as the y coordinate or how far up it is. So that first student who got a 70.45 homework average and a 66.4 test average, that would be, I think, this dot right here. That's over 70 and up approximately 66. These two dots way up here are the two students who did really well, like over 100%, because there was bonus points apparently. They did really well on both homework and tests. So for all the dots, the further to the right they are, the better that person did on the homework. And the further up they are, the better that person did on the tests. And it looks like mostly the general pattern is that dots that are further over to the right also look like they're further up, and dots that are further over to the left look like they're further down. And you can't really connect all the dots just by drawing a line through them, but if you drew a line that was as close as possible to the dots, it would look something like this, and it would go up from left to right. Later on, we'll talk about that line and how it's determined. That's coming up in the next section. And down here, I've got this number R equals 0.746 and so on. And that is a number that measures kind of how closely these dots line up in a straight line. That's something called the correlation coefficient. And I will come back and explain more about that in a little while here. But basically, the closer that is to 1, the more perfectly the dots line up in a straight line. So here, the correlation coefficient is 0.746, which is pretty good, but not perfect, not real good. Here's another example. In a statistics class, do people with higher scores on the first test usually end up with higher overall grades for the class? Like, once I've given that first test and graded it, do I pretty much know how well people are going to do overall? Not for sure. Just because somebody scored well on the first test doesn't guarantee that they're going to get an A for the class, and just because they score poorly doesn't guarantee that they're going to fail. But in general, I would expect that high scores on test number one would go along with high final grades, and low scores on test one would go along with low grades. So here are some actual numbers, some actual data points from a previous semester. So for all the statistics students I had that semester who made it through the semester, here's what they got on test number one. Here's what their final grade was. And here are the dots, the scatter plot. And yeah, it does look like the further over to the right the dots are, the higher up they tend to be. Here, the correlation coefficient is around 0.85. That's pretty high. That means it pretty much is true that students who did better on test number one did tend to do better overall for their final grade. How about this one? In a math class, is there a relationship between absences and grade? That is, do people with more absences who missed more classes tend to end up with a lower grade? Well, you'd think so, but let's look at some data. Here's for one of my classes from the previous semester. For everybody in the class, I've listed how many absences, how many excused or unexcused absences they had from class during the semester, and what their final grade was, like as a percentage. So the first person on the list, they had 19 absences. They missed 19 classes over the course of the semester, and they ended up with around a 38%. They did not do very well. The next person on the list just had 2 absences, and that person ended up getting around a 90%. There were some people with 0 absences. They never missed a class. Some of them did sort of well, final grade in the 70s. Some of them did really well, a final grade of 100 or more. But mostly it looks like, oh, and here's somebody who had 14 absences but still ended up with a C. So mostly the people with lots of absences had a low final grade, and people with not very many absences had a higher final grade. And here, if you look at the scatter plot, the dots that are further over to the right tend to be further down. More absences tend to go along with a lower final grade, and only 0 or 1 or 2 or a small number of absences tend to go along with a big number for the final grade. So here, the dots tend to go down from left to right. We would call that a negative correlation. And when you look at the correlation coefficient, it is a negative number. It's negative 0.832. And all of this, I'm going to come back and explain in more detail exactly where it comes from and how it's calculated later on. These are just some examples to get us used to thinking about what we're dealing with here. Next question, is there a relationship between how many letters there are in a student's name and the grade they get in a statistics class? Like, do students with longer last names get higher or lower grades than students with shorter last names? Is there any relationship between how many letters there are in somebody's last name and how well they do in class? Well, you wouldn't think so. And when we look at the data, it kind of looks like, yeah, there's not really any relationship. You've got some people with like 8 and 9 and 10 letters in their names. Some of them did not do very well. You got some people with 3 or 4 letters in their last names. Some of them did not do very well. Some of them did better. In general, though, it doesn't look like there's much of a relation between the number of letters in somebody's name and what their final grade was. Probably could have predicted that. I mean, why should there be a relationship? But it's nice that it doesn't look like there is. The dots in the scatter plot are kind of all over the place. They don't look like they're lining up at all, or like that the dots further over to the right are all down here or all up here. The dots further over to the left are kind of all over the place. And the correlation coefficient, well, it is a negative number, but it's not very negative. It's fairly close to zero, negative 0.4896 and so on. So what we're talking about in general here is the kind of question we're addressing is, given two variables, things that vary, are they related? And if so, how? Like, does how big one of them is tend to affect or go along with how big or small the other one is? Like, for example, you might want to know, is there a relationship between the number of hours people spend studying for a test and the score they get on the test? Is there a correlation between the number of hours people spend watching TV and the number of hours they spend reading? Like, do people who watch lots of TV do lots of reading, do very little reading, or is there no relationship at all? Is there a relationship between income and number of children? Like, do people with high incomes tend to have more children or fewer children than people with lower incomes, or is there no relationship? Is there a relationship between the temperature outside and the number of crimes reported? Like, are there a lot more crimes on a hot day than on a cooler day, or vice versa? If you're in charge of advertising or marketing for a company and you're looking at buying advertising on the radio, you might want to know, is there a relationship between the number of radio ads that we run and our sales? Like, if we have more ads, will we have more sales? Will we sell more? If not, then there's probably not much point in running more ads. But if there is a relationship, we'd like to know about that. Is there a relationship between the score that an incoming college freshman got on their ACT and what their grade point average in college turns out to be? Like, can you predict how well somebody will do in college by something like their score on the ACT test? So those are some examples of things that might or might not be related, but we'd like a way of studying and calculating and investigating whether there's a relationship and how strong a relationship it is. Now, a simple relationship would be one where there are just two variables involved. A multiple relationship is when there's more than two variables. Like, how well you do in a class might depend on how well you do on the first test, and how well you do on the homework, and how many classes you miss, and various other things. But in what we're going to be doing here, we're going to stick with simple relationships where we're just considering two variables at a time and how or whether they relate to each other. But if you dug deeper into the subject of correlation, you would have to look into multiple relationships among all sorts of different variables in certain situations. A positive relationship is one where the two variables tend to go the same direction. The bigger one of them is, the bigger the other one tends to be, or when one goes up, so does the other. And a negative relationship is one where they go in opposite directions. So the larger one of the variables is, the smaller the other one tends to be. When one goes up, the other goes down. When we're studying two variables, we often designate one of them as the independent variable and the other one as the dependent variable. That doesn't mean we know for sure that it depends on the other one, but if we think it might, we call it the dependent variable. So if there's one of the two variables that you can manipulate or control or try different values for, that would be the independent variable. And then if you want to see if some other variable is influenced by that or depends on that, that other one would be the dependent variable. Okay, this video is running long, so I'm going to stop here and come back in part 2 and we'll pick up there. See you then.